is scale this thing right here to be 8.5 by 11. Super easy to do. I'll just use the scale command. I'm going to select one of the corners of the page. Everything all right? Okay. I'm going to select one of the corners of the page as the origin point. Whoops. I'm going to select the other side of the piece of paper, right here. And I know that I want that edge to be 8.5 inches, so I'm just going to type in 8.5 inches. Okay? Now, this thing is this dimension. Oh, I'm in feet. Okay. Well, it's 8.5 by 11. And that's what's nice about the scale command. If you don't know what it is, don't care what it is, you can reference the start and end point of that dimension and type in what you want it to be, and it will be that.
You type in the inches code, or do you type in like a specific?
I mean, it depends on what units your file is in. But yes. For example, I'm in feet. If I typed in 8.5, it would give me 8.5 feet. I had to type in 8.5 quotation mark, inches to get inches. Okay. Okay. So there's my 8.5 by 11. It's the size of a piece of paper. Okay. Now I want to make this the size of that garden. So I'm going to scale it up, right? How many times am I going to scale it up? How much bigger am I going to make it?
96.
Why?
It's an 8 scale drawing.
Mm-hmm. How do we know that it's an 8 scale drawing?
I just recall that from last quarter.
That's fair. But what we could do, there's a couple ways we could verify. If we had this printout, we can use like an architectural scale and measure something. We could also look at the graphic scale. And we could even do it in here in Rhino, right? I could do distance. Since there's nothing to snap to, it's going to be kind of, in the air. Let me just change it to inches real quick so I can make up the points. Right, so that's almost about an inch, right? So if 1 inch measures 8 feet, then 1/8 of an inch measures 1 foot. That's a standard scale, right? And the scale factor for 1/8 inch scale is 96. So I'm gonna undo that, and I'm going to scale this. And the first thing it asks me for is scale factor, and the scale factor for 1/8 inch scale is 96, because that's how many times 1/8 of an inch fits into a foot. It's basically 8 times 12, right? Questions about that? All right, cool. And now, for our purposes, and to make sure that we practice good modeling, we're done with the image in terms of measurement. I'm going to say this 3 times, and someone is still going to do it. We're not going to trace it. We're not going to trace it. We are not going to trace this image. Okay? Are we tracing this? Good. One reason we're not tracing it is because there's nothing you can snap to. It's accurate to some degree. There's some degree of accuracy. But first, there's nothing we can snap to, right? So if I wanted to draw the edge of this pool, if I click here, right, I'm going to leave my mouse right there, and as soon as I start to zoom in, let's say I clicked there, right? If I zoom in, that's how far away from that corner I was. Okay, what if I'm, out here and I say, oh, what if I just, I do it really quick, like boom, boom, right? If I click there, that's how far away my click is from that. So, right, there's no degree of accuracy when it comes to trying to trace an image, right? Another reason why is, let's say I draw a line. I'm going to get as close to this edge as I can. Draw it down. Right? This drawing is crooked. The line on the left here is the one that I drew using ortho, so I know that it's perfectly straight up and down. This is the line that was drawn on this plan. It's crooked. And since we can't snap to that other line, we have no idea by what degree it is crooked, right? And finally, say I move this line over here. If we look at the plan here, this line that's hand-drawn, you know, it delineates a certain area. I think this is maybe a turf area. It doesn't matter at this point. If I zoom in, let's say that that was drawn with like a micron or something like that. We can measure the thickness of that line, right? You know, if you used a 0.1, that's what is that, a 0.1 millimeter? Is that how they measure the thickness? Either way, that line has a thickness, a line weight. What's the thickness of this line?
Very light.
I don't know. 0. There is no thickness. It's infinitely thin. There's no, I cannot touch it, I can't grab it, I can't measure it. The thickness of that line is 0, right? We only see it because Rhino is showing it to us, right? So that's another difference between why we would not trace this. Because let's say I knew, let's say I knew the width of this planter here, right? Let's say it's, I don't know, 8 feet, something like that, in this area. Well, if I wanted to measure 8 feet, where do I measure from? Do I measure from the outside of this line to the inside of this line? Do I measure from the outside of that line to the outside of that line? Is it only that white space in between? Is it the midpoint of the drawn line? There's no way of getting, you know, a perfectly accurate measure. When it's on an 8.5 by 11 and I hold my scale up to it and I see like, oh, okay, yeah, it's about 8 feet. It's about 8 feet, right? So because of the difference between drawing with pen has a thickness and drawing with Rhino has no thickness, that's another reason why we don't trace images. If you had no measurement to start with, tracing is sometimes okay, but again, we are not tracing this. So, having said all of that, all of the measurements we need to recreate this are in this drawing. What measurements can we use to start drawing this? Sorry? The walls? Possibly. The pool. Yeah, that could work too.
About the tiling.
Tiling. And so that grid on the ground, what's the size of that?
5 by 5.
And everything else in this space, if you look at it, is either grid or not grid, right? So the entire space has just a giant 5-foot grid slapped on it, and the only difference between what is grid on the ground and what is something else is whether or not that piece of grid has been trimmed away or not, right? Because this pool is 2 by 2 by 2 by 4 by 3 by 10 by 1 by, right? So it's modular. Everything in here can be broken down by that grid. So let's draw the grid. I can start with one line, and to make sure that it's 5 feet across, I could use the offset command. I can specify the distance as 5 5 feet. And when I click, that line is 5 feet away. When I click the next one, repeat the command, that one is also 5 feet away. I can also use the copy command. Say I wanted it to go this way, 5 feet. I can do that. If I wanted to copy really quickly, I could select the last piece in that copy. And this will be the first instance where I tell you to copy something without actually snapping to what you're copying. For example, if I snap here, and I want to copy 5 feet over, the only way I can do that is by typing in the number. But if I reference the line next to it, which I know is 5 feet away from it, and I click there, and I start moving my mouse, I have this ghosted image in here where that copy started from. And now I can say, since I know that that distance is 5 feet, I'm copying this thing from 5 feet away. Basically, you can think of it as from -5 to 0, right? And I can keep doing that, right? Because every time I click, it's going to make a copy. And I can keep referencing the next one, and the next one, and the next one, and the next one. Does that method make sense? Okay, good. That's my preferred method of doing things like that. You can also do them multiples at a time. I could select all but one, right, since I need to reference the one before. I'm going to reference this one before. If I selected all of them and reference the first point of copy, where I end up copying to, I'm going to have a duplicate line, and I don't want that. So if I reference the line before, and then copy it to the very last line in my selection, then I don't get that duplicate. If I want to see that difference, I can exaggerate it here. That point there was the reference point between here and here is 5 feet or whatever that distance needs to be. And when I move my mouse this way, it'll snap here, which was the last item in my previous copy, and it will copy all of these right there. Works the same way as the individual copy. You can just do multiple at a time. That's probably more than enough. Now if I go the other way, say I draw a line to it, I could use a array linear command. And the first step is sort of, I guess, unless you knew exactly over what space you needed that grid to happen. Let me put in, I don't know, let's say 30 items. Actually, let me go back a step. I need to offset it once so that I can establish that distance. And then instead of copying that second one, I'll use the array linear. I will do 30 items. So what that's going to do is take that, and I'm going to define a distance by which 30 of them are going to be copied out. And I needed to do that offset so that I could reference this 5-foot space here, right? And as I move this, before I do that second click, we can see all of those 30 items, moving out. And then when I do that, each one of them is 5 feet across. And now I've got my grid going in that direction. 30 was too many, but there we go. Does that make sense? Okay. Get rid of some of these because I don't need all of them. So now I can, since I described the pool as being trimmed out of the grid, that's exactly what I'm going to do to create the pool. I'm going to select a large area of lines that I want the pool to exist in. I want to select more than it, so if I knew that my pool was ultimately, I don't know, 5 by 10, I wanted to select more than that. But if I select everything that is going to be involved in that trim operation, enter trim, when I get into the command, everything that I click will then be deleted. So I haven't entered the command. I selected all of those lines, and now if I type trim, everything that I click on will be deleted. Right? That line goes away. And I can just start making the pool, right? So that first row is a 2, second row is 2 squares, third row is 4 squares, fourth row is 4 squares, next one down is 3 squares, the next one down from that is 3 squares. Okay. So there's my pool. I just use the trim command out of that grid. Does that make sense? So now that I've got that pool in there, I could count the rows and columns of grid away from that to see how much grid because I have too much grid here, and I kind of want to limit my area of grid so I don't get overwhelmed or start counting incorrectly or anything like that. So to the left of the pool, I have what looks like 2 grid spaces, right? One grid here, a portion of it here, a portion of it here, and then the wall of the building. So I'm going to say 2 grid squares to the left of the pool. So 1, 2, that line right there, that's my building edge already. And I can use that to trim away those lines and delete the rest of those. Going down from the bottom of the pool, I've got 1, 2, 3, 4 grid squares. So 1, 2, 3, 4. This line right here. I can trim away all of this. End up deleting those ones. To the right of the pool, I've got 1, 2, 3, 4, 5 squares. So 1, 2, 3, 4, 5. Use this to trim all of those. Get rid of all those. And then moving up from the top of the pool, I've got 1, 2, 3, 4, 5. It's I think it's 7 because this one isn't quite 2. 1, 2, 3, 4, 5. Let's do 6. So I need one more actually going up. I'm using, if I want those lines, these vertical lines that don't quite meet to meet this line here, I can use the extend command. And the extend command works by first selecting a boundary and then by selecting what objects you want to extend to that boundary. And now all those lines get extended to that boundary. Okay? So now this should be the limits of my garden space.
Of your what? Of your what limits?
Garden space.
Oh, thank you.
Okay. Let's see, what could we do next? We could define the edges of the paving. And I think what I might do first is work on this area here because there's sort of some irregular measurements. We could go back and use the distance command, but in the other 2 sections of the class we've agreed that this is 1 foot wide here, and then this is 18 inches wide, so we'll just keep it consistent. So from this edge of the pool, I'm going to offset this 1 foot this way, and then this 1 foot this way. And this line ends up getting trimmed. And then this line here ends up getting offset 1.5 feet this way. my paving over here. So then all of that goes away. I might have to draw in some extra lines later, but for now this is fine. Okay. So that whole left edge, right, that's there. And then on the bottom edge of the pool, I've got that little piece, and then 1, 2, 3. Then over here, 1, 2, 3. This edge and this edge. I use trim because I don't need any of that. Right. And then I have this walkway here that goes all the way up, and it goes up to the top square of the pool here. That's where this one intersects. So if I use trim again, I don't need any of that. And then this walkway here. And this walkway here. This only goes up for 2 squares. So I don't need any of this. That or that. And then if this one here again goes up 2 squares, and this edge of the pool goes here. That. And then from there on up, it sort of changes, which I will end up redrawing, but right there is more or less the basis of the paving, right? We do have that walkway that goes on top, but we're going to have to shift it by an amount that we'll figure out, because that part sort of breaks the grid a little bit. But the rest of that, there's our paving, right? How about some walls? So this one right here, that's easy to draw. I'm going to put it on a different layer. This wall right here, that lines up with this grid point here and is 3 squares long. There's one side of the wall. And then we've decided that all walls are going to be 8 inches thick. So I'm going to offset it by 8 inches. There's the wall, and then the fountain goes in there. How about, there's a partial wall that goes here. But the end of the wall here doesn't really line up with anything. It sort of lines up with the bench here, but we haven't drawn any of that in, and I don't want to worry about that. So, for something like that, we could actually still use the distance command. Let's say I get as close as I can to as close as I can. About an 11-foot wall. Yeah. Close to that. So what I'm going to do is draw another line from here, straight out, 11 feet. I'm just going to delete that other one. And then I'll give this another offset of 8 inches. Oops. There's There's that wall that goes there. And I can't really draw the rest of the walls until I get into drawing the steps. But before I do that, I think maybe we should make some things 3D, right? So we have the pool. Why don't we make the pool 3D? And this is a lot simpler than it sounds. So the first thing I'm going to do is I'm going to draw another line that represents the boundary of the pool, because if I try to, in terms of the geometry I already have, if I try to select the boundary of the pool, right? If I tried to extrude that down, that would be a mess, right? I can't do that. So I'm just going to draw another line that is the boundary of the pool.
Using polygon, right?
Yes. Okay. So there's the edge of my pool. And now what I'm going to do is I'm going to draw the pool in section. And the way that I'm going to use old school drafting methods to figure out how I can do that. And what I will do is I'm going to snap to sort of each horizontal change in the pool, and I'm going to draw lines way off to the side. I'm going to use them as guidelines or construction lines. I'm going to draw this over here, draw this over here, here, and over here. And then, actually, I'm just going to rotate it. So now, if I drew a line, right, I can measure it, but that would end up being, the sectional quality of my pool, right? Because this is the start of the pool. That's that first edge of concrete. That's that second edge of concrete. That's the end of the pool. Does that make sense? Okay. So what I'll do then is basically decide on the depth for my pool. Oh, how deep do we want the pool to be? Yeah, let's do that. 8 feet, that sounds fun. In the other classes, they're saying 5 feet. That's not a fun pool. Okay, so I'll draw one line here, and I'm going to copy this line. So if the shallow end is 3 feet deep and the deep end is 8 feet deep, then there's a 5-foot difference between those two. So I'm going to copy this 5 feet this way. And then this line is the slope between the shallow end and the deep end. Right. I'm going to join those lines together. And then before I use those two lines to basically intersect each other and make the pool, I'm going to use the fillet command. Have you been using that in drafting? Okay. Yeah, it works the same way. I'm just going to give that angle a bit of a curve. And I think maybe a 5-foot radius would be okay for this. Yeah, super subtle. That's nice. Okay. So I'm going to, actually I'll just copy this over here. I want to rotate it to be long ways with the pool. And now I want to go into perspective, and instead of it being flat, use rotate 3D to prop it up that way. Right? So I will take this, the boundary of the pool, and extrude that curve down, and I'm going to extrude it way down. I'm going to change this to ghosted so you can see. And then what I'm going to do is extrude this curve way more than I need to. And then I'm going to move this to first intersect with the pool, and then move it vertically -3 feet, so that the shallowest point is 3 feet. And now I can just use those two things to trim each other. So I can say this trims this, and this trims that. And there's my pool. You can join the two together. Normally we don't see pools like this, they're already in the ground. Right? Okay. We can, there's sort of a second pool we can make, being that little fountain right there. Typically fountains like that are not very deep, maybe like 6 or 8 inches, but we'll make it like 1.5 feet. I noticed that in the other sections, the more detailed I got into what we were doing and why we were doing it, the more it became a construction class. So I'm sorry, but you're going to learn a little bit of construction. So -1.5 feet. That shouldn't have the top surface. Scratch. There we go. Okay. So this next step is going to be very construction oriented. So we have this 5-foot grid here, right? And as far as we understand what that grid is made of, it says concrete decking. That could mean that it's poured all at once, and then they put scores in concrete. They do that so it doesn't break. You can do that pretty much at any interval, but because it says decking, that could also mean that they are precast concrete pieces somewhere in a factory somewhere. You order them and you set up your pedestal or your sublayer, and you put all of these 5-foot by 5-foot pieces on the ground rather than pouring it on the ground. In either case, there's space between each of those 5-foot by 5-foot pieces, right? Which in our case would mean that the paver, that square itself, we'll call it a paver, that's going to be smaller than 5 feet by 5 feet because we have to account for the gap between each of them. And rather than modeling that ground surface just as one solid surface, we're going to model each and every little square because that will give us a deeper level of realism when we start texture mapping and rendering. Okay? And so the way that we can do that is I'll take this just bottom square here, I'll draw a rectangle, and I'll first trace that exact 5 by 5. And then I will select that rectangle, and I'm going to offset it to the inside by a distance of 1/16 of an inch, and that would mean that the space between it and its neighbor would be 1/8 of an inch, which, so a score line maybe isn't much thicker than that. If it's a gap joint, it might be a little bit thicker. If it's what's called an expansion joint, it might be much thicker. We'll keep it at 1/8 of an inch. Right? So the offset will be 1/16 of an inch. 1/16 of an inch. There we go. I'll delete my original. Very small, very kind of unnoticeable, but when we render, it makes a huge difference. So I'm going to turn this offset rectangle into a planar surface. Get rid of that outline. And now I'm going to, because we are going to have height differences between where we walk and where it's planted, it's going to be subtle, but it needs to have thickness so there's no air gaps between anything. We're going to extrude this 4 inches. Okay? So this little square that is 5 by 5 minus a 1/16 of an inch all the way around and 4 inches thick, that ends up being our paver. Okay? And what's nice is since we offset that 5 by 5 to create the next one over, all I have to do is copy it by typing in 5 feet, 10 feet, 15 feet, 20 feet, 25 feet, so on and so on, right? And if I zoom in, I still have that gap in between because it's copying that whole thing 5 feet across. It doesn't matter if that thing is, 1 foot wide or a mile wide, it's still going to be 5 feet across from center point to center point. Does that make sense? And I think that's the easiest way to copy, because if you tried snapping to things, if you didn't zoom way in, this would be another thing to be careful of. Let's say I tried copying from here, and it said snap. What am I snapping to? I'm snapping to something, but if I'm not zoomed in, I don't know if I'm snapping to this, or this, or this. And because they're extruded, and I'm looking down in top view, there are 2 things that I could be snapping to here, right? That top corner or that bottom corner, right? So in this particular case, this really sort of drives home that, attention to detail, zooming in and out to really verify what you're snapping to. It really sort of drives that level of precision so we don't make silly mistakes. So, which is why, in this case, I would prefer copying things based on known measurements. 5 feet, 10 feet, 15 feet. I can still do that from top view if I want.
When you were making a copy to the pool, it deleted that area?
I'm sorry?
When you were making a copy of the one line going towards the pool, how come that one got cut off?
Yeah.
The pool does it?
No. No. When I can go back to 3D and show you. Go here. It's still there.
Oh, I see. From a different angle.
Let's see, is there one? No. For this this area, these are all the same. That's different. That's different. That's different. That's different. And those 2 are the same. So you're gonna have to. The 5 by 5s are easy. The ones that are a bit smaller, if you'll do it, it'll just take a bit more time. I'm gonna just go ahead and do that, the smaller areas, but I'm gonna use the same method. I'm going to draw in a rectangle, make sure that I know what I'm snapping to, offset it by the same amount. turn it to a planar surface. I'm going to extrude it -4 inches. I actually did all of this at home last night too, so this is the 4th time I've done this week.
How many classes do you teach?
This quarter, 5. 3 sections of graphics, the lecture for graphics, and a 203 studio, which is 125% of full time. So that's fun. So there's a couple things that we might want to do to the pool now, right? If I zoom in, I can see that the pool overlaps with the pavers. That doesn't make sense, right? But I can't just scale, in one dimension. I can't just shrink that pool down because the pool does not have a common depth to it. So what I can do is I can draw a rectangle that kind of just, over encompasses this whole thing here. Turn that into a surface. And then I can move that vertically from wherever it is down to, let's say, here. And then let me select pool as well. I can use that surface that I drew to trim that overlap in the pool. So now the pool starts 4 inches down. We can do another modification to this later when we add in like coping and a drain and all that kind of stuff. Definitely not necessary, definitely doesn't show up in any of the plan or section drawings, but in terms of the rendering, we'll give it that next level of detail to make it more photorealistically believable. Let's see if I can do the stairs in 20 minutes. So, here's the stairs here, right? And the reason why it breaks the grid, well, I don't know the reason why, but it does break the grid. So this area is flat as a landing. Then you step up, and you step up, and you step up. So there's 3 steps going up to this level. And right here, that still looks like that same 5-foot grid, right? So between the flat of this landing and the back of the top of the second step, that's still within the 5-foot grid. We can still use that measurement. The next one is the width of the stair, and maybe up to here, maybe up to here, maybe that's another grid point, but then here, that's definitely less than a grid. So that, 5 foot, 5 foot, 5 foot, it breaks down a little bit right here. But we'll get to that. So, let's just, for the time being, go to here, and we will use one of these as the basis for that landing and that first step, right? This right here. So, how are we going to figure out how to split that up? Well, it's definitely not in half, right?
Looks like it might be thirds.
Yeah, it's about a third, a little more than a third. If we go, actually, we could again be a little sneaky about it and just measure this drawing here, and we see that the length of the stair here is 1.5 feet, 18 inches. That's much larger than standard. Those are those wider stairs where you have to go like this to, to climb down, just because they're longer in length. But for your private garden, that's fine. Standard tread is between 11 and 13 inches, but we'll draw it at 18 because that's what we measured it at. So what I can do here, what I'm actually going to do is, you know how we have that gap between everything? I'm going to incorporate the gap into the paver rather than the stair, because in terms of construction they would be made differently. You would have the paver up to the stair, you would have a thicker expansion joint, and then you would build all your formwork for your stairs and you would pour that. There are precast stairs, but there's not a lot. And then when you make grade, then you continue all of those pavers. That's third year stuff, but we're just going to treat them separately. So what I'm going to do is I'm going to shrink this down this way, and then I'm going to model in the stairs separately. So if that stair is 18 inches wide, what's the remaining length of that 5-foot paver? 5-foot paver.
3.5 feet.
3.5 feet. So I'm just going to scale, use scale 1D to only scale in one dimension. And I'm going to say now, it's going to work the same way as that first scale that we did. I'm going to say from the beginning to the end. I know what it is, but I don't care what it is. But I'm going to type in that I want it to be 3.5 feet. All right. So there's my shortened paver right there. Okay. And now what I'm going to do is I'm just going to, I can do a plan. Use that rectangle here to draw the boundary of my stair. Okay. I'm going to make that a surface. And now, how tall is a stair?
Foot.
The foot is too tall.
6 to 8 inches.
It's within that range. It's usually between 4 and 7. That's a good range. We'll make these 6. That's very standard, just half a foot. It's easy number to work with. Usually for the outdoors, like for like a public space, it's about 4 inches. For like a fire escape stairwell, it's about 7 inches. So that's really like kind of the variables why all stairs look different, because you can change the stretch of the accordion and then the length of the landing. But so our stairs are going to be 6 inches high and 18 inches deep. So I can just take this surface and make it 6 inches. There we go. We're gonna do something else to it, but later. If I look at the plan again, I have another step, exactly the same, 18 inches deep, 5 feet wide, 6 inches tall. So I'll just make a copy of the one I just made. I will copy this stair from corner to the other corner. Here's my second step. If I go back to plan, I have a third step up, but it's much longer. It's okay. It's still the same dimensions because I know I can stretch it. So copy from here to here. It's not long enough, but there's my third step. And now I can just use that scale 1D command to stretch this scale 1D from its original dimension to, actually we can't go to the next grid line. Why? Because the next grid line is not 5 feet away from it. I don't know. We could measure it, but it looks like it's more than 5. What do you think it is? 9 feet? I don't think it's 9 feet.
Looks smaller than mine. 8 feet.
About 6.
Wow.
Yeah, it's about 6 feet. So what I'm going to do then is, since I know that this line is, oh, I don't know that. Ooh, interesting. That's easy to do. I can just scale 1D and say from here to here is now 6 feet. Right? But now what I need to do is to find this next mark at that same line so I can make this walkway here. So what I'll do is I'll just move it to coincide here, and then I'll move it vertically from here to there, right? Now that line is where the top walkway starts, and I can copy it 5 feet this way. Now, this, that line, and that line, and that line. There's that top one. But I'm getting a little ahead of myself. The last thing we want to do for the stairs here is, even though this probably won't show up in the rendering, I may or may not make you make sections of this. So if this geometry is more or less accurate, then the section is easier to draw. I'm just going to make each of these steps coincide with the thickness of the paver here. So I'm going to stretch this one to here, I'm going to stretch this one to here, and I'm going to stretch this one to here. Just using the scale 1D command. Scale 1D. Here to here, now matches up with here. Here to here, now matches up to here. And here to here, matches up with here. Right? Doesn't change anything about how we experience the stairs, but it's kind of good modeling practice. If you wanted to further, you could select all 3 of these and use a Boolean union to make them one object rather than 3 objects. If you wanted to go a little bit further, kind of an advanced trick. If how do I explain this? If you're working with super complex geometry and you do this next thing that I'm going to show you, it probably won't work and it will probably mess up your geometry, in which case undo it and just never do it again. But the command is merge all faces. And the reason I want to do that is even though I've done a Boolean union and this is one object, I've got 3 faces that represent the side of this object. And in terms of texture mapping, let's say I put a concrete texture on this. The way that that image applies to this geometry, I'm going to have the same image, stretch this way, and then next to it stretch this way, and then next to it stretch this way. That's not the way that we texture map things, and that's incorrect, and it looks terrible, and it's ugly. But if I merge all faces, which is the command, it's going to turn these 3, and then everything on the bottom and everything on the other side, it'll turn that into one face. So, merge all faces, and now that side is one face rather than 3. Okay. Don't have to do that. Just a bit of an advanced trick if you wanted to try it. Okay. I can put in the rest of these pavers for this top row, and then we can take a break. So, why don't I offset by a distance of 1/16 of an inch inside inner surface. And then this sort of entry, or I guess exit area. I don't know. I don't know. Every time I do go through this, I always picture this as a front yard rather than a backyard. I don't know. I've never seen anyone with a pool in their front yard, but it kind of, I don't know. That's the way I've always pictured this space. So to me, that's a front door and not a back door. Don't care. Doesn't matter. We don't have the rest of the building to know. Maybe it's not even that. Maybe it's like a patio or a community something, right? Maybe it's not even one person's house. I don't know, I've just always thought of it as a front yard. But so this area right here, we can proportionally look at the lines to figure out what it might be. If this is 5, this is probably what, 2? Probably 2, and there's 1, 2, 3, 4, 5. It's a 6 by 1, 2, 3, 4, 5. So a 5 by 6 of 2 by 2, so it's 10 by 12, right? We could also measure, say, just verify that. Yeah, it's like exactly 2 feet. So what I will do is from here, I'll draw a line that's 10 feet this way, and 12 feet this way, and then I can copy it again use the same rectangle method. Offset it by the same amount. Turn it into a planar surface. These ones would probably end up being thinner since they're smaller, but we're going to extrude them the same amount. And this one, instead of copying it over 5, I'll copy it over 2. 2, 4, 6, 8, and I can select all of them. 2, 4, 6, 8, 10. Select the curves to hide them so I don't select them. Select all of these, show everything, and then move vertically from say here to there. There is our surface. I guess just before we break, if I switch this to a rendered view, select those lines in the pavement now have nothing to do with like a texture map. It's physically lines in the pavement because there's space in between there, light doesn't get in there, it shows us the shadow, all that kind of stuff. Right? That's why we do that. Okay? Alright, so take a break. See you at 12:30. And we will finish the rest of this and do a little bit of rendering by the end of this class. Yeah, we'll do some cool stuff. By the way, that channel, Vsauce, I recommend watching everything they have on there.
Wait, what?
The video that I showed is on a channel called Vsauce on YouTube. I recommend just watching everything they have. Vsauce.
Oh, okay.
Yeah, they do some really amazing stuff. All right, I'll see you in a bit.
I'd be fine words past it, get it, and then you want to follow the PowerPoint, and then you go with PowerPoint, rather words were not matching what he was saying, so I didn't even have reference in terms of, like I really was, almost like I was being smacked the whole time.
I can't remember where I am. So tan,
So even space
so
words,
tan.
like
You
you
don't
have
even
to
more tan than me.
stuff is the whole time you're.
I'm always red.
You have that class.
I was just working red.
But then when you go back on, yeah, I did not. But I did Rhino, I did pretty good. But this class, I just because I would be making more corrections on a class that was closer. When you started,
Yeah.
when he wasn't even
You need to
fast,
use your
and
will.
then he also had like a stuttering problem or something, because he would.
You too, huh?
And the word would rush out, you know, kind of quickly, so I don't know if that was a stumbling problem or if it was just him knowing that he doesn't pronounce the words quickly, because I know sometimes like he would look and I would try to not make a face, because I think I would also make him uncomfortable. Because he wasn't used to me sitting there and having him
I
go
thought
over.
you
And I was thinking, who the hell else is understanding what he's saying?
So for us, we don't have that option, but I think faster can do still most.
Yeah, if you want it to.
Are they really getting it? What are they asking?
Do too fast and cool.
Yeah.
Okay.
He just said that.
I said the same thing.
It's not as fragile.
Look, it's not fast and he doesn't.
Yeah,
So it would be appropriate to
Yeah,
give
that's
them
fine.
an instructor.
Yeah,
Yeah.
just like the days do it. But just, you don't have to use it.
But it's also probably slower.
Stop making me forget how much I normally do.
So about like, can I just use
I said the same thing to somebody. Because.
Or you have to bring them all
But
12.
when they hire them, especially, well, you should have discriminate like that, and those that say, especially when they hire
Oh,
them, they should have them,
they have
we should have them at a class, or have them interview like they're giving a class for, even if it's only a 10-minute presentation, so that you can see if he's understandable. Because I don't know if like they were doing, I mean, of course, when you're in a class after a while, you start to understand things a little bit more, especially if it's the same topic. I don't know if it's the same topic. If it's the same topic, like.
26.
And after a certain point, you begin to understand, okay,
Yeah.
he's
26.
saying this word, you know, and you kind of get it for the semester, but.
The same size as that. Wi-Fi. 36.
Well, I had
No, just the one, just the 6 of the.
Yeah. Home, and I was like, well, but I didn't understand how this was saying, so.
Look,
So.
I got a mini version.
No.
It was
36.
zero. Well,
Sides,
after a while,
sides
you get it,
and
but at least
plan
in
and
math,
photos.
the terms are all the same.
36.
So even though half the time I can understand him,
I'm
after a
pretty
while,
sure
I'm like,
it's
oh,
36.
he's saying delta.
Well,
So
you have the 12,
or whatever,
right?
kind of catch it, and then we're gonna repeat. So the math terms always stay the same. But if you go in a class where,
Yeah.
you know, like history changes because you're going on in history, or this was an IBM class, so I'm
Three
sure it changes
three
every
drawings
class.
each.
No, we need 3
But
drawings.
you don't know what he's saying in each class, because each class is different. There's no common,
No, I said
No.
plan.
you know, thread